Alright, so today we're diving into the fascinating world of solubility-based separation methods. These techniques are essential in chemistry for isolating and purifying compounds based on their solubility properties. In this video, we'll explore three primary methods: extraction, filtration, and recrystallization. By the end, you'll have a solid understanding of how these methods work and when to use them. Well, let's get started. Extraction is one of the simplest and most commonly used methods to separate a desired product from a mixture. The basic idea is to transfer a dissolved compound from one solvent into another solvent in which the product is more soluble. This method is grounded in the fundamental principle of like dissolves like. Polar substances dissolve best in polar solvents, while nonpolar substances dissolve best in nonpolar solvents. When performing an extraction, it's crucial that the two solvents used are immiscible, meaning they don't mix and instead form two distinct layers, much like oil and water. By shaking these layers together, the solute, our desired product, can transfer from one solvent to the other. Let's consider an example. Imagine we have a solution containing isobutyric acid dissolved in diethyl ether. Since isobutyric acid has a polar carboxyl group, it is more soluble in water, a polar solvent, than in diethyl ether, a nonpolar solvent. By adding water to the mixture and shaking it, the isobutyric acid will move into the water layer, also known as the aqueous phase. To separate these layers, we use a piece of equipment called a separatory funnel. Gravity causes the denser layer to sink to the bottom, where it can be drained off. Typically, the organic layer is on top, and the aqueous layer is on the bottom, but this can vary depending on the relative densities of the solvents. To maximize the extraction efficiency, the process is often repeated several times with fresh water. This is because a single extraction might not transfer all of the desired compound into the aqueous layer. By using multiple extractions, we ensure that most of the product is extracted, much like washing clothes multiple times to remove all the dirt. Interestingly, the reverse process of extraction, known as a wash, can be used to remove impurities from a desired product. Here, a small amount of solute is used to extract impurities from the compound of interest, rather than extracting the compound itself. Next up is filtration, a technique used to separate a solid from a liquid. This process is similar to using a coffee filter to separate coffee grounds from the liquid. You pour the mixture onto a filter paper, allowing the liquid to pass through while retaining the solid on the paper. There are two primary types of filtration: gravity filtration. Here, the solvent's own weight pulls it through the filter. This method is generally used when the desired product is in the liquid or filtrate. Hot solvent is often used to keep the product dissolved in the liquid. Vacuum filtration. This method involves using a vacuum to pull the solvent through the filter. It's more efficient and is typically used when the desired product is the solid, also known as the residue. Lastly, we have recrystallization, a method used for further purifying solid compounds. This process involves dissolving the impure solid in a minimal amount of hot solvent and then allowing it to cool slowly. As the solution cools, the solubility of the product decreases, causing it to recrystallize out of the solution. The key to successful recrystallization is choosing a solvent in which the product is only soluble at high temperatures. As the solution cools, only the pure product will crystallize, leaving impurities dissolved in the solvent. This method is particularly effective for obtaining high purity compounds. So there you have it, a comprehensive overview of solubility-based separation methods. Whether you're extracting a compound, filtering out a solid, or purifying crystals, these techniques are essential tools in the chemistry lab. Understanding how and when to use each method can greatly enhance your ability to isolate and purify compounds effectively. If you enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe for more chemistry insights. And if you're using the King of the Curve app or web app, make sure to like and comment on what topics you'd like us to cover next. Check out the app for more detailed content and quizzes to test your knowledge. Thank you for watching, and good luck studying.